Hello everyone and welcome to this new CATIA Design User Talk. In this format, our users will introduce you to their innovative way of designing, modeling, and visualizing their projects in CATIA. This time, we will dive into the fascinating world of aerospace design by discovering NTNU Propulse, an autonomous student rocketry team from Norway, which aims to reach space with a self-developed liquid fuel rocket. To achieve these goals, they work on every step of the engineering project, from the design to the production, test, and launch phases, using CATIA and Dassault Systèmes solutions. And so to present the designs of the cooling channels of the combustion chamber done with CATIA Visual Scripting, I have the pleasure of welcoming Anders HESTAD, one of the students from the team, Edouard SUTRE, CATIA Visual Scripting expert,
Hello.
and Maxime CHAGNOT, CATIA expert at TECHNIA. Hello, guys.
Hi.
Hello, everyone.
Thank you very much for joining us today. Before to start, maybe I will ask you a quick introduction of yourself, starting by you, Anders.
Yeah, hey. So I'm Anders HESTAD. I'm a fourth-year electrical engineering student at NTNU here in Trondheim, Norway. I've been part of Propulse also for 4 years at this point. I've been avionics lead for a while, and then now I'm doing various things on a sort of R&D project on the side.
All right. Edouard, it's your turn.
Yeah, so hello, everyone. My name is Edouard SUTRE. I'm part of CATIA R&D organization, and I'm responsible of the strategy and the product evolutions for CATIA Visual Scripting, and I'm also an expert on this solution. I'm happy to have Anders as a guest today, but also Maxime. So Maxime, if you can introduce also.
Yes, hi everyone. My name is Maxime CHAGNOT. I'm a CATIA expert working at TECHNIA in Norway. And I've been following NTNU Propulse since 2020 and helping them starting with 3D experience. So I'm very proud to have Anders today showing us his project.
Yes, right. We are very proud to have you, Anders, today. Before to start, I would just like to remind viewers that they can ask their questions in the chat, because we'll take some time at the end during the Q&A session to answer them. And so we can now deep dive into the project, but before, I would like to ask you, Anders, first question: what is NTNU Propulse?
Yeah, so I have a little PowerPoint here. Propulse NTNU, we are, as you mentioned, a student organization here at NTNU. We started in 2018 and have been making a few rockets ever since then. Currently, we're about 85 members in total, so that's crossing a whole bunch of studies and fields. These are our previous rockets. We've gone to competition with these. I was personally part of project 2021 and 22. And then I've been a mentor since 23 and up to now. I'm doing some R&D stuff also. The latest main project engine is the following. It's a bipropellant liquid engine. And we're planning to launch this in the summer. That's upcoming now, late summer. But then this talk is about, or more closely related to our R&D project, Project Hoppen. And so this is the engine that we will be looking at today. It's gotten a little bit newer ever since this render also. Keep working on it. But it's a bipropellant test engine. It's a little bit smaller, 2.5 kilonewtons. Ethanol and LOX. We're doing thrust vector control, so we're gimbaling the engine. We have 2-pass regenerative cooling, film cooling, which is injected in the throat, and then we hope to deep throttle this engine. So that's sort of the scope and motivation behind this CAD I've made.
All right. Yeah, very good introduction, Anders. Thank you. And so I see now the full model on screen. Can you tell us a little bit more about it?
Yeah, so as you can see, this is only the lower bit of the engine. The top part is the injector, which is made by another member in Propulse. That bit is made in Part Design and the generative shape design app. But this section is entirely made in Visual Scripting. So they're melted together in Part Design in a small assembly with just those two parts, but I guess I'll just walk through some of the scripts that this bit is made of. I guess it's worth to show that the part body is just a single add design. Everything is made in Visual Scripting, and then I've decided to sort of melt it together in Visual Scripting also. The very start of the script is the base. So to get the inner engine profile, we have external software which calculates this and outputs just a list of points to the array, if you will. And then it's quite easy to just import this as text into the Visual Script, and I'm able to dot out some points and create a spline based on that. So if we ever change the engine or engine parameters, we just change the list, and then everything else will follow. Going forward, we have the channels. So this is the biggest script that we have. I think I could have separated this into some more bits at some point, but this script starts by making the geometry we see here. So we're making just a bunch of profiles, and then I'm able to create some guides and such to make a loft. For this, we're controlling quite a few things, just the number of channels that we have around here. We're deciding sort of a minimum spacing here, which is kept constant along the entire body as we go around. And then the more interesting parameters is the twist, the sort of helical shape that this plays out, is decided with a little like slider graph. And then finally, the cross-sectional area, which ends up in being how tall are the channels going to be. And so again, just being able to import lists and then sort of applying this to geometry. They're not the same dimension either. I'm able to do some resampling in the scripts. I'm then able to sort of, for every one of these profiles, calculate exactly how tall this channel should be based on an external optimizer script that we have running. Going forward, this script, kind of in parallel to this, creates some film cooling geometries. So this film cooling has 3 inlets on the bottom here. And then we're creating this manifold that stretches across 1/3 in this case, because we have 3 inlets. And if I put a section view here, we can see that there is some more geometry which takes this manifold shape and then guides it up into a channel where it gets fed into the engine wall. And so again, it's quite nice being able to generate these. All I'm inputting as a parameter is the start area here, and then it slims down into, I think I have it set to 10% of the cross-sectional area at the end here. And then all of this other geometry is also being decided just by a couple dimensions. The issue we encounter with this is that the cooling channels and the film manifold crash. So the rest of the script is kind of handling this and the inputs. So we end up folding the cooling channels around the inner manifold. So you can see there's kind of a line at the top here, and then there's another line at the bottom here where we've just cut out a section of the channels, and then we've using the inner geometry here. I create some sort of guiding geometry in the script, and that allows me to create some profiles where it folds around here, and as we get further to the end, this fold gets larger, and then at the very end there's quite big displacement to make space for the inlets themselves, because we want to control this film cooling externally, kind of with a separate valve and such, so we can either have a lot of cooling to be safe or go lean and be more efficient. Of course, to actually feed fuel into the film, we have another revolute at the top here. Again, we're just the sort of input parameters to this is the area I want to start at, and then at the bottom. And then just based on the geometry internally here, how many sections of film cooling, it automatically sets up the outlets and the sort of shrinking of the manifold area based on that to get it all distributed evenly. And then the width here is just decided by how large this displacement and such is. So the general workflow has been to minimize the amount of parameters you decide, because we're able to kind of find out what's the most optimal solution and make the geometry figure itself out from that. The end of this script is just kind of putting a shell around everything and closing it all. And then this is the biggest kind of single script that guides, or generally this is the engine, so to say.
So all scripts are connected, in fact.
Yeah, so using the published geometry from one script, this is used as an input into the next scripts. Nice. So if I were to update this script, then the rest would want to be updated, or yeah, it will do it in line, so to say. So to look at the rest of the scripts, which take geometry from this one, we have the ISO grid, which is quite nice. All we're setting is sort of the density of the grid itself, and then some parameters on how thick and tall we want this to be. I can try and open the script, actually. So yeah, here we can see it just about. To control the height, we just have a sort of graphical interface slider where I can decide anywhere between a minimum and maximum height that I want. Let's see if I can show this. The little special thing about the ISO grid is we've managed to make it pretty robust. And so the main chamber, the main project, we've utilized this same script, and they got to print their engine last week. And we can see it here in its glory, not departed from the build plate just yet. And so we're able to print this geometry quite nicely. And this script was effectively just copy-pasted from my visual script onto a different chamber. The only input to this, yeah, here it's loaded. The only input to this visual script is this surface right here, which is just the cylindrical shape of the engine. And then using some parameters to set the thickness and density of the pattern, we're able to generate the entire shape procedurally. So I guess I'll just scroll through here so you can see some of it.
Yeah, right. So this is a really nice graph.
Yeah, I think it's worth showing off that a little special thing about this part is that we're compensating for the overhang, kind of, because we're printing it from this direction, as you saw in the picture. 3D printers can't print in free space, so we're specifically controlling this angle to be well, an arbitrary angle, but 45 degrees is what our printer is limited to. And so even when the contour kind of curves in, we're still keeping this 45-degree angle constant as we go to make sure that this is actually printable. Yeah, remaining parts of the script here now is the DE power thermocouple parts. So we want to measure the temperature of, let's see. Yeah, we'll keep this. The temperature of the internal channels. And so we're dotting some ports around the outside there. This, if I can open it, also has a pretty nice sort of interface, because the most practical way for us to control it is just this little list, which is the channel number. So we have 36 channels right now. So this goes anywhere between 1 and 36. And then we're setting the height on the chamber where we want it. So doing this in order, we're just sort of deciding the location, and then you can also see we're able to procedurally put sort of identifying text on them as we go. This script we've reused for the depowdering ports at the bottom, because we're planning on printing this engine with the chamber and the injector all in one piece. We need to take the powder from the print out, and so we have some holes at the very bottom here to drain the engine. Finally, we also have the thrust vector control mounts, which are just decided by placing a sort of center point here, and then we have some values to decide the thickness and height and so and so. And then also logos or like images is something which we've struggled with on previous years, because importing SVGs when you don't have SVGs isn't the easiest. But there's some nice functions in the Visual Script where you can just take a JPEG and then it'll find the corners and such. And so I have a little preliminary frog for a logo. And then this is just a JPEG which we're able to convert to geometry and then project and fold around the chamber quite nicely in just the script.
Really nice on that. It's really, really impressive. I have a lot of questions for you, but I will try to just ask a few of them, especially around the learning phase of visual scripting. What I understood is you learned almost everything by yourself. Is it right?
Yeah.
Can you give me more details about it?
Yeah, so I got access to the Visual Script in September last year, I think. And so when I picked it up, I knew nothing. I wasn't sure where to look for tutorials either. So the workflow was generally just open the Visual Script app and then click through the different boxes that you have available. And then just by reading like a little tooltip and trying my way forward, I've managed to work up a knowledge of sort of how to generate certain patterns and shapes and find the geometry. But it's been a learning curve, and I think I've gotten quite proficient in it at this point.
Yeah, I'm pretty sure, yes. and what kind of softwares do you know, in fact, before using Visual Scripting?
Yeah, so I've been doing 3D modeling since middle school, but starting in Blender, which isn't really a CAD program, it's just for rendering and such. But I've built up some experience there, and then in high school I started using Fusion 360, doing kind of part design things there. And then when I got to university and I joined Propulse, I got access to CATIA. Or a little bit later, I got access to CATIA about, I guess, 1.5 years ago now, where I've only done some part design stuff. So when I hopped into visual scripting now in September, with about a year of CATIA under my belt and a lot of part design experience, it's a bit of a learning curve, but the sort of big change that I've had is I've gone from a part design build set where you extrude stuff and revolute it to working with wireframes and surface design. So I've come to understand that the workflow that I'm doing in visual scripting now, which is much more similar to generative wireframe and surface design. So it's much faster to do operations, and a bit of the nice thing with visual scripting is just being able to drag parameters around. So the geometry updating fast, because I don't have to wait for Boolean operations, is certainly an advantage.
So if I'm right, this full model is in fact driven by a lot of parameters, but at any time you can change any of them and it will be fully regenerated, right?
Yeah. At this point, it takes a little while to update, especially because of all the fillets that I've applied to the various geometries, but It can do changes quite far up into the tree, and the changes will just kind of work. Not always. It's a bit of an iterative process. At the start, the script is a little bit unstable, and then you drag a thing and you realize, I never accounted for generating this geometry, and then you fix it, and then things like the isogrid, for example, become very robust.
Okay. I will let the others asking also questions, but thanks a lot, Anders.
Yes, I think now we can move on to the Q&A session. But first, I want to thank you, Anders. It's a very complete presentation and really impressive, as Edouard said, to see all these detailed and complex scripts. And you learn that very quickly. So it's really, really amazing. So yeah, now let's move on to the Q&A session. And it's time for you, viewers, to ask questions and take benefit of our expert presence. So please don't hesitate to ask your questions in the chat. And I think while you are writing your questions in the chat, Maxime, you have some questions to ask to Anders.
Yeah, exactly. I thank you, Anders, for the presentation. By the way, it was very clear, very nice to see your design.
Thanks.
And I had a question regarding the rest of the team. So did you help the rest of the team also to learn visual scripting? How many people in the team can now? Can you give us a bit of an update on that?
Yeah, so I'd say it's around Christmas. Some other people tried picking this up. I'd say 3 or maybe a handful of people have tried it, but I think there's 3 guys that have sort of picked this up quite nicely and actually used it for some stuff. One of them is this main engine that I showed a picture of here. So HESTAD, who made this, has made not entirely, but most of this is visually scripted. So the cooling channels and the manifold you see at the top here, as well as, it's a little bit hard to see, but there's like a downcoming tube on the outside and such. And then, of course, they had to tweak, and they did their own modifications to the isogrid to fit it to their looks. But this is mostly visually scripted, and he's found out a lot of that on his own. I've gave him some advice and tips and tricks, which I think helped. And then there's also at least another guy who used the visual script to put some like isogrid-like patterns in sheet metal parts. So just taking sort of a flat, or the profile of a flat sheet metal part, and then putting some, I think it was honeycomb holes, which avoided all the edges and all the holes, which looked quite nice.
It's nice to see some collaboration, and it's very nice that they can also reuse some of your script as well. I find it very useful.
Yeah, absolutely.
I have another question also. So, for example, for the truss vector, you said that you used visual scripting, and when I see that, for me, it could be also a very simple part design bit. But I want to know, I know you discussed that also with Edouard, but I just want to know, did you fall in love with visual scripting that you feel like a part like that could be done just with visual scripting then?
Yeah, so it's, I think it's a little like you said, that I've kind of fallen in love a little bit with the application. So, I mean, I guess to sort of take it down, well, what the road that led me to doing this in visual scripting is just that it started out with thinking the cooling channels, which is quite complicated geometry, and I know we have a sort of external script or simulator which we want to take parameters from. It was like, this is perfect for visual scripting, because there's a lot of repetitive sketches and profiles and such to make. And then as I got more comfortable, it's like, yeah, okay, well, the cooling channel ports, or the thermocouple ports, this would also be really nice to visually script. And then it's like, okay, well, actually, this part isn't that different. And then it's kind of just, I'm a bit of it's a little bit of a mindset where if I want to make a part, it's, could I visual script this? Where I've ended up.
And as you said also earlier, everything is fully parametric. So it would be sad to have a sketch-based version while everything is fully parametric. So I understand that too.
Yeah,
and,
having everything in one interface Having everything in one interface is super nice, not having to jump between Sketcher and part design and shape design and some tables where you have parameters and such. It's really nice.
I understand. Maybe my last question would be just what is the next step for that part? Are you going to print it in additive manufacturing or metal printing? What is the next step for
Yeah.
this?
So we've been doing a number of plastic 3D prints. I don't have any of them in hand now, but we've printed the chamber itself in entirety, I think, twice now. And then the film cooling section, especially, we've printed a couple versions of as we test to see is the geometry actually usable or not. And it's the last version now looks really nice, the one that is in this code. The one that's in the render for this show did not work particularly well.
Indeed, it looks nice. That was for my question, Alan. So if you have a question in the chat.
Yeah.
Yes, we have some questions. Thank you very much, Maxime, for those questions. A first question, maybe a basic one, but it could be nice to have a reminder. It's just how the script works, how the app is working, how CATIA Visual Scripting is working. Maybe Edouard, if you can just give just 1 or 2 sentences about the app presentation.
Yeah, in fact, the main app used here is CATIA Visual Scripting. It's a visual programming application where you describe the sequence of operations you want to use in order to generate geometries using nodes, and you connect nodes together. It's really simple, and it's a big trend today, also in the engineering field. So that's all for this first point, mainly. I also see a basic question, but of course this talk is recorded, right, Alan?
Yes, exactly. I've seen some questions about the recording. It will be available right after in replay on LinkedIn, YouTube, and in our CATIA design and styling community. I will share the link afterwards, of course.
Anders, you wanted to say something?
Yeah. I think because there's quite a few other alternatives which exist for creating or scripting or programming CAD models. But I think what really separates the visual scripting app from most of these is that you plunk down one of the blocks or one of the features, and then you get a geometry which instantly updates. You don't have to run a program and wait for it to generate. And then also the thing I think which makes this pretty special is that you don't end up with a sort of mesh-based voxel representation of the parts. You end up with, I think it's called B-rep, right? Like a boundary representation, normal CAD geometry, which you can combine with normal part design. And stuff that you get from what I've seen isn't that. It's kind of pretty hard to put into a normal CAD. And so with this chamber, me making the bottom half and my friend making the injector on the top in part design, it's really practical that we can just kind of melt these together, and it's completely normal CAD stuff. It's not any funky conversions or things like that.
It's definitely a good point. You're right. In fact, CATIA Visual Scripting is using the CATIA technology, the CATIA kernel about the geometry, so it's fully compatible with the rest of CATIA applications. Maybe we can take more questions, Alan?
Yes, I've seen 1 or 2 more questions. One is, how did you do the spiral cooling channel? So it's more for you, Anders.
Yeah, so generally the workflow is just I take the profile that I generated. I have to offset it a bit so I don't make it inside the wall itself or like on the surface. And then that's the kind of nice part of visual scripting is where I now am able to separate this into I discretize it into points. And then I'm able to rotate each of these points however much I want. I do a little bit of math as I'm only controlling the overhang, so I have to find out how much I need to rotate each of them. But this is just a little bit of math, some cosine, sines, and trigonometry. And then using a sort of helical path, I'm able to build out the rest just from that shape. And then the discretizing itself is also quite nice because I'm setting just a resolution I want on the path. So I say I want about 5 millimeters between each point, and then it'll find out by itself how many points that should be given the engine I'm currently designing.
All right.
I think we also have a question regarding tutorials.
Yes, I will do a reminder at the end, but of course, the CATIA Design and Styling community is the place where you can find all tutorials, tips and tricks, and all any materials to learn how to use CATIA Visual Scripting and all the apps related to CATIA. Yeah.
And if I may, we also have a dedicated CATIA Visual Scripting community and also YouTube with tutorials. But I don't know, Anders, if you were able to get them, or did you try to use tutorials available, or you tried?
I did look at some of the YouTube stuff actually. Yeah. Some of the I can't remember which one. One of them I think was a pretty good inspiration to where to start for the isogrid, I think, specifically.
Okay.
But yeah, mostly it's learning by myself, but I did get some inspiration actually, for sure.
All right, I see a lot of other questions, but we'll need to close for today. So thank you very much, Anders, Edouard, and Maxime, for your time and participation. And thank you to all the viewers who watched this CATIA Talk live. Of course, as I said earlier, if you want to watch the replay, you can watch it on LinkedIn, YouTube, but I really encourage you to watch it on our CATIA Design and Styling community, because you will be able to ask directly questions to our experts on the dedicated post with the replay, and also to watch tutorials, tips and tricks, and any materials to learn how to use CATIA Visual Scripting. And as Edouard said, we also have a dedicated CATIA Visual Scripting community with the links that I will share later on the different channels where this talk was displayed live. Of course, let us know your feedback in the comments for the next CATIA Design User Tools, and I see you for the next ones. Have a great day and goodbye, everyone.
Bye, everyone.
Bye.